Okay, back to another one. So anyway, we have this animation going now. It was a little finicky in Firefox, which I'm glad I worked through it because it just made sure that I got the code right. What I ended up doing, and I ended up looking at this person's code. I couldn't copy it just straight over. Like I had to just go study what they did and see what their implementation was, just for a refresher. Anyway, so there's a pretty good article here. Problem is it's slightly outdated, or at least for Firefox, it'll probably work in Chrome. I even struggled with it in Edge a little bit, but I got it working there as well. The problem with with Firefox, was that it needed a web server to run on, and so I needed to launch a web server. So these tutorials, they will work if you're going to host them on a website. However, if not, either using Edge or Chrome should do the trick. I think Chrome's available for just about everything now. Could be wrong. Not sure about whatever. Can't think of Mac's version of the browser anymore for some reason. I guess too long of a day for me. Anyway, I know they have their own. Haven't tested Opera, but anyway, all this stuff should ultimately work. It's following web standards. It's just because of browser security and the updating of browser security within the last few years anyway. The tutorial that I walked through doesn't quite work because of, for the most part, because of this. Not only that, I didn't quite agree with his implementation. From what I was reading, by and large, I understood what he was saying, but I wouldn't want you to go down that same path. So we're just going to go through it. I'm going to go through my code somewhat line by line to a certain extent. So let's recap where we were, just in case you're seeing this later. So we ended up making a bunch of images, right? We rendered out frames 1 through 80 on a weight circle, and then we rendered, or we used a plugin inside of Gimp, and we rendered out or we compiled a sprite strip image, and so it's just all of these images compacted into one image file, and that's mainly for the speed of operations of having to load one file and not have to load any more files to access the frame-by-frame information that needs to be immediately available. So we put it in one image, and that's the sprite sheet, and then we're putting that into a web page. So here's what that web page looks like from the code perspective. And it's not super long. It's not necessarily super flexible at this point, but I believe it's structured well. So let's go ahead and go through it. There's a couple technologies going on here. This is an HTML file. An HTML syntax has a opening and closing syntax, meaning I have like this head bracket, for instance, or this head declaration. To end that, we do the same declaration, except for we put that / at the beginning of the word head to say that's the end cap, and then anything in between there is what the head has, and then we could do other things like we could set a style, we could set the type, and we should set the type, so text, CSS. Otherwise, if we don't set the type, it won't work. And then we end the style, and then we put our information of style in the CSS syntax inside of there. So there's a few different languages going on. inside that can go on inside of an HTML file. So one of those is the CSS styling scripting language. The other is JavaScript primarily. Sometimes you'll see VBScript, but that only works in older versions of Internet Explorer, so we're going to ignore it. And plus you have the HTML syntax. There's other technologies like SVG for drawing shapes and things like that. So there's all sorts of crazy stuff. And then there's this Canvas thing. This came out as an HTML5 technological improvement to the web standards, so that it gets its own element and it's its own thing, so we can draw things in a Canvas tag according to the HTML Canvas standards. And it's a WebGL capable thing that we can use. So actually, I'm kind of moving around here because I'm not quite at a desk right now. Just trying to get situated and get my trusty old coffee. Give me a second. I want to drink it while it's warm. So anyway, there's a lot going on. I'm going to try to just briefly walk you through the structure of these things. So right here in script, as soon as we're in a script tag, we're writing in JavaScript. So this everything here inside of that script tag, this is all JavaScript. And it interacts with the HTML document that is, part of the body of the HTML document. So we're going to be interacting primarily, at least in this case, primarily with this Canvas tag. And we give it an ID of can, just for short. And you'll see once we start walking through that, okay, what do we begin doing? So I have to explain a couple little things. We don't have to go into huge amounts of detail for it. We can later on, but that's not the intent of this one. If I did it now, I'd kind of lose you in the details, I think. But I can explain it briefly from the outset. So what we're doing is we're creating a new image. So saying new image, by default, JavaScript has access to the image API or built-in function to create an image that the Canvas tag can take advantage of. And it has a source property or .src, and then we give it a file path of like where is that image found, okay? And so this is a variable that stores this new image. It's just a blank image, doesn't know what it is until we tell it the source of what it is. And then it goes and reads up the information from that actual image file, and that's all we really need for now. And then we create this, what I call a sprite. So we made a sprite sheet, right? We made the image sequence of all smacked into one image file, and that's what this image contains. So we need to make an object that represents the actual sprite house, the unit of what that sprite is, that one sprite is, I guess, that sprite object. So this is an object definition, but it's contained within a variable. And then, because it's an object definition and it's object-oriented programming, this stuff works kind of neat. So I consider it like blueprints to a house. So you have a blueprints to the house. I can take those blueprints and I can go find a lot of land that I want to build that house on, and I could build that house. Now, if I wanted to also go find another lot of land that house would fit on, I could also take that same set of blueprints and go make a new instance of that house somewhere else. So that's basically object-oriented programming. So just like you would have, this plan's kitchen, and this plan's bathroom, and this plan's garage, and this plan's floor material, and this plan's number of doors in the house, and those kind of things. These are properties to all that. So same thing for our sprite. Our sprite technically has 80 images. What I realized is that frame 1 and frame 80 are exactly the same. So it kind of pauses the animation. So I just reduced it by 1, meaning we don't ever have to render the last one because we already are on the first one. So that's the reason for the change there. Anyway, we're defining what our sprite object is, and it gets the context from the canvas, and we'll see that in a second. But when we create this new sprite, we're passing in an object, which we're calling options in this case. So this is a parameter that gets passed in. So we have a function that's built, and it's kind of a template, and we pass something into that function, which as soon as we pass it in, that function itself says, I'm going to call you options. So options with this property, options with that property, I'm going to make sure you are getting assigned to whatever I tell you to, because you're in my house now. So that's what this function is doing inside of that. So as soon as we pass in a parameter, we call it options, and now we know that, okay, options.context, we're going to call you this object's definition of context. We're going to set you equal to that. And this object's definition of width, we're going to set in whatever you passed in to be .width property. We're going to assign that to width, and so on. And it's just going to keep going on. And then at the end, we just return this object. And we do that so we can chain properties together. It's kind of a trick. It's a neat trick. We don't have to return it. We can still access everything if we didn't return it. Returning it just helps do some other things. So I'm not going to explain the details of why at this point. So then we have other things. We have these are called methods. So every object inside of JavaScript has this what's called a prototype property to it. And then we're able to define new things on the prototype. And if we set them equal to a function, that becomes a method of that object. So this doesn't quite, maybe it does, maybe it fits the definition of a house. Let's say we have a sink object that has a faucet property or a faucet object inside of it in the kitchen. And the method is turn on the water. Okay. So as soon as we say house 1 that I built on property 1, kitchen sink, turn on faucet, well, that's a function. And then we say, okay, this dot faucet equals running, this dot faucet dot temperature equals warm or lukewarm or cold or hot, or you get the idea. So we get to do all sorts of things with that. So then, but it's on the sprite object. So in other words, our house object would have this faucet object inside of it, which would have properties and methods of those things. So anyway, I'll stop at that. So this one, clear rectangle, is just saying we'll get the context of what we set context to be when we first created this object. So go get that context. And then context has a clear rect, which is a clearing rectangle. It clears a rectangle from coordinates. So 0, 0 starts at the top left, and then it goes width, and then it goes height downward. So top left, and then to the bottom right. So x comma y to x comma y plus width plus height. And that's the way that works. And it's like it takes a virtual eraser and erases that frame, and it just makes it clear again. It's kind of like shaking an Etch a Sketch. It just clears up the screen. So it does it really fast. Okay, and then we have this render method on the sprite object as well. And I'm just making some things local. I didn't have to do this. I was, again, testing some validity of the code. But instead of having to type this all the time, I was able to just type in width and height, because I was able to just define some local variables inside of here and call them those things. So this renders the frame because the context also has a draw image method, and it takes in the image parameter, which we set the image, and that was the first thing we did. We told it where an image was, and we created that. We told it the width and the height, and so this has frame information like. Let's see. He did have a good article on this part, which is why I would still somewhat refer you to it. Where is it? Yeah, here we go. So the context.drawImage method has these properties. So source X, source Y, meaning where along here, source X and source Y is where along the strip. So if I want to pick this frame, I'd say SX is here and SY is here, and then of course my frame width and height for each one of these frames, I could just increase it from that each point as I go through that sequence. Anyway, these are all the properties for that, so it explains what those are. So yeah, SH is the sprite height and sprite width, I guess, or source width, source. I don't know exactly what they're calling S, but that's what they use. Anyway, but that's what we're passing in. We're passing in those values in that order for those reasons, for these reasons right here, over on the right. Okay, and then we'll move forward. That was a pretty cool diagram, I thought, because it helped explain all this. And then we have an update function. Sorry, I keep saying function because I see the word function. It's an update method. The difference between a method and a function, there isn't one really. It's just that a method belongs to an object. A function just happens, right? I mean, it's so generic it doesn't necessarily belong to an object. It's just a function. So if you're not trying to think in an object-oriented way, you could still not do that, create a bunch of functions. And we actually had to create a separate function outside of the object-oriented way of thinking, just to make all of this work, actually, which kind of, we lost a little bit of flexibility in some of that because of that, but that's okay. It made it all work really well. So anyway, let's get into what this is. So it's the update method on the sprite, and it's basically just keeping track of the frames. So when we first initialized it, we set the frame to 1. So we set the frame to 1 because that's the starting frame. We want it to start at 1. And then we want it to loop through 79 frames total. So from 1 to 79, that's where we want it to go. So every time we call this update function, it says if this frame, which is the frame number it's on, if that frame is greater than or equal to 79, or the maximum amount of frames, then we need to set this frame back to 1. We need to start over. We need to start the animation all back over again because it's completed its cycle. It should never be equal. Or sorry, it should never be greater than. But just in case, it doesn't hurt to put it there because if for some reason a function, for some reason a method didn't fire for some odd reason, then if it ever detects it's greater than, it can at least pull it back to, as fast as possible, pull it back to where it needs to go. So it doesn't just keep trying to iterate and not render anything valid, because anything beyond that 79th frame, there's no image information. So you have to be able to pull it back to frame 1. Okay? If it's beyond that or equal to that, set it to 1. Otherwise, just set it to what it currently is, plus 1. So if I'm on frame 1, plus 1 is 2, and plus 2 is 3, and you get it. That part's not hard. Okay. And then we're getting our canvas object. So now we're starting to interact with the HTML document. And this is how we do this. So JavaScript has access to the document that we're currently in. And we can get the element by the ID, and if you remember, we set that ID to can, C-A-N, right here. Canvas ID equals can. So we're able to get that right there. And then we're able to set its width and height properties. I set this to the actual Sprite's image size that we rendered out, which is half a 1080, because we rendered out at 50% of 1080 by 1080. Okay, and then here's where we actually create the new sprite. So just like we have, our blueprints or our floor plans for how to build a house. Okay, we actually have the property now. We're saying, hey, okay, we're going to build you now. So we're now going to create a new version of that definition we're going to create a new sprite. Remember, that was what we just walked through. Created the definition of sprite. Now we're going to make a real instance of this sprite. Apologize. A lot of talking. Anyway. Okay. So notice that there's parentheses inside or at the sprite, because sprite is really a function, right? If you look at it, sprite is a function that we have to pass in options to. Well, options is an object, and we know it's an object because it has these dot properties to it. Objects have properties. That's what has properties. So JavaScript has this cool little object notation where we can do a curly brace. We can type out the property name. We put a colon, and then we give it the property value. So in this sense, we define canvas. We got it. We got that element. We said, okay, go get window.canvas.getContext. Window just means the window of the HTML document. It's kind of hard to explain, but it's the actual window of the application. So they put their variables in that part of the API. That's just the way they call it. So when we don't even have to use it, I could delete that and everything would be fine. Oh, it references this one. It just makes it clear. If you put it, it's more exacting, I guess, if you keep it there. But not necessary. Alright, so width property, height property, image property. And then we said, okay, we created an image property with our weight circle all the way up at the top. That was the first thing we did. Var weight circle equals new image, and we told it where to go find it and all that. So we have all that. We have everything we need, and so we're going to create a new sprite. And then this was unnecessary. This was a test I was doing, so ignore that. I'm going to erase it for now. And then I created an animate function. And this is, like I said, this is a function that doesn't belong to an object. It's just a function. I hard-coded this function, which it's not the best idea, but there's ways around it. Like we can keep track of things in a different way, but this is just to get the animation working. We can go through what it means to add more flexibility to code later. But this is just to get the animation up on the screen. So we created this function animate. If we're going to do a animation loop, it's expecting a timestamp for the parameter to the function. I'm not really passing one. I'm just putting in a placeholder for it to be there so one can be put in. Because that's what's being expected by the rules of this request animation frame, whatever function that is in, it needs to have a timestamp passed into the function it is inside of. So I just put it there. But now notice, remember we created an instance of the sprite definition, right? So now we're able to use this method, render, of this one. So in other words, if I said house 1, turn on your sink, I don't want to say house definition, turn on sink, and expect that to turn on every house's sink. That doesn't make sense. It's just a set of blueprints. But now I have a real instance over on property 1, right? I have this property 1, house 1, and I'm saying, do this. So now I'm saying, okay, this instance of this sprite object, go render your object. And then, after you've rendered it, go update your, remember, update just increments the frame to get it ready for the next one. And then, when we request the animation frame, what happens is it issues it, it calls this. So it's saying, as soon as you can repaint, a new image on the screen, call this again. So then it calls render again and update. And inside of render, it calls the clear method. I don't know if you did it. Yes, it did. So it says this.clear. That's this right here. It's this object's clear. Okay. Method. So it goes in there and clears it, and then it goes and draws the image again with the whatever frame location it is for however far over on the X value that is. Okay, and then it updates it, and update again just increments the frame number so we can keep drawing a new picture because it's a multiplier. It affects the multiplier over there, and then we're done. And then we just call animate. So this again, this is a definition, is a generic one, but then we call it, and then it calls this object every time. It just keeps rendering it. That's it right there. So let's go ahead and walk through that briefly in a. So that's this exact file right there. And let me make sure we save that. Right? We save that. I'm going to refresh that. Just to make sure it's all working, because I did remove some things that I told you I could remove them, no problem. I could remove that window, I could remove that counter object that was sitting there doing nothing, that I didn't clean up. So all that's working. Alright, so we're going to copy this file. Okay. I'm going to call this test plant, because we made a plant version, or a plant sprite sheet. Where did I put that? I think I put it on my desktop. Plant images, sprite, plant. Okay, so I'll copy that and put it over here. And I'm going to call this test plant underscore. I'll keep the caps all the same. Okay. That way it follows the same. So now we just need to put test plant inside of this one. Alright, so let me, I'm going to go ahead and drag this over to our text editor. So open it up, and then instead of this, we're going to say test plant. Okay. And I don't remember how many frames we rendered out on that one. It might have been 60, might have been something else. Let me open up that file actually. I've never saved this one. That's ridiculous. I should have saved that. Let's see, desktop. Actually, I didn't want that. No, I didn't. I wanted. Nope, wrong one. Damn, wait circle. I'll just put wait circle. Okay, we're going to save that file. Now I just reopen it. So open recent plant project. Now I just lift this up, I believe. We rendered 25 frames. Well, that's what I'm going to consider we rendered. I don't know exactly what our sizes were. Resolution. Okay, so it's every 400 pixels. So 400 by 555. That's a horrible, horrible, horrible thing to do. I want to do this at 1080 we're going to do 1080 again. We're going to do it the same. We're going to keep it the same this way. All right. And then I'm just going to do 25. So I'm just going to re-render this goofy thing. We'll go back through the process one more time. It doesn't hurt. Just do it faster. That's all. All right. I'm going to actually put this where the file is. Let's go back. I need to go into. Oh, man, I messed up. I'm thinking of a different machine, I think. I need to go into that directory. I'll put it in here, and I'll make a new one. I'm just going to call this test plant images. And I'm going to accept that, and then we're going to just re-render all those. This might take a little while. There's some materials on these. It's not just a flat color on. There's actually, this is a 3D scene with 3D lights and shadows and everything. So yeah, it's going to take a little bit of time, not too much, but it's only on frame 4 of 25. So anyway, let's go back then while that's happening, and I can see it happen down here at the bottom, so I can tell if it's when it's done or not. Okay, so if you are using Firefox and that's all you have, I had to go and get, and I've been using these tools for years, but I had to go and get my this is a development web server for PHP and MySQL that runs on Windows. I had to go get that so that this is running as a fake web server, so to speak. It's running on my machine, but it's running through the network ports. So when I typed in 127.0.0.1, that just meant go to my local machine. That's a reserved HTTP port for the local machine, and you could get through it through there. Port 80 is already in a web browser. That is the default. So anytime you go to like google.com, it's coming through port 80. If you need to change that for some reason, like I could go to port 443, I believe I can. I'm going to go ahead and go over there and do that. I should be able to just do a colon and then 443. Hit enter. It's a bad request, but anyway, if it were a valid one for a browser, I could actually do 80 here and it would work fine. There we go. So 80, and it automatically assumed it, so it just stripped it out of there. But if I had to say that was 8080 or 5000 or something like that, and you have to stay within a certain range because there's reserved ones. They're called TCP ports. Anyway, if things aren't working because for some reason it won't let you just go there, you might have to put in an 8080 or something like that. Anyway, are we done? I think we are done. That was actually pretty fast. Okay, so now we need to go render. I need to get Gimp running again. Remember, because this is where we build our sprite strips. I'm just going to save this. And I'm going to close it because it's just taking up memory at that point. We did all of our render work. So I'm going to say File, Open as Layers. I'm going to go Browse to my, where is it now? Come on. Where's it? Oh, I'm missing time. C drive. Oh, it put it to the top. That's weird. Okay, htdocs. We need to sort by name. There we go. Oh, that's weird. Alright, we need to go in a wait circle, test plan images, and I'm going to hit Control A. I'm going to hit open. And then, of course, it'll take a few minutes, or shouldn't say a few minutes. There's only 25 of them. It's already basically halfway done. Alright, that looks really funny because it's see-through, so you see what's behind the next one. But you can tell it's definitely moving. It's definitely moving some distance. Alright, and then we'll just say filters, sprite sheet, create from layers. And there we are. There we have it. So this is a 540. There's 25 scenes to it. I want to export as, and then I want to get back to the same folder. Xamp. We already have a picture image. Actually, it's just I don't like the size it is. So I should just be able to overwrite it. There it is. Export, replace it, export. Okay, now that's done. Now, I'm going to close this and get it out of the way. Discard the changes, please. Discard the changes and close Gimp altogether. Okay, and then I'm going to minimize that. I'm going to open this guy up. Okay, so now we have the test plant. I know that's true. We have 21 to 25 frames. So I could do a sloppy trick here. I could just say 26, even though I know there's not 26, because the logic in this file said I can go all the way up to 1 minus 1, right? So I'll never end up to the last one, so to speak. So I don't know. That's not true. I'll say 25. That wasn't true. I apologize. I had to think through that. So that's why we don't do sloppy things, because I could quickly make a mistake. Anyway. Yeah, that should actually just work. So let's go have a look, because I would actually like to change this. I would like to change the behavior of this. And I think it would be a fun little exercise just to get us in there figuring out what we can change, because by and large the footwork's done. Like all these functions and all these object constructors and all that, for the most part it's there. We just have to do a little bit of modification to get other things working. So we're testplant.html. I'm going to duplicate this tab, duplicate, and then instead of wait circle, we're going to say test plant. There we go. And the monkey-headed plant is moving. Okay, so there is a few things that we could deal with. One, this thing is flying super fast. It's flying super fast. So I didn't put any speed control in the functions. It's just going as fast as it possibly can to repaint one frame to the next. And it's actually doing a pretty good job at it. So anyway, let's go ahead and modify it. So we could put in a delay. The delay would be, that's where we could then put in like a counter. We could put in a counter object in there to then say var counter equals 0. And then we could bury all of that inside of a bigger if statement. So we say if counter is less than 10, but we could also do a speed object now. We could go build in a speed definition or sorry, a speed property, I should say, on the sprite object definition. I'm not going to do that right now, but we should. That's the right way to do this. If that is less than 10, let's not do anything except set the counter. I'm going to show you a shortcut. Actually, I'm not going to show you a shortcut. You should. I want to make it super plain up front. +1. Okay. Otherwise, we're going to do this. Okay. And then, sorry, I should be doing that. There we go. Otherwise, we're going to do that, but we also need to do one little thing, and we need to set counter equal to 0 again. So now, instead of doing this every time, it's going to only increment the frame 1 out of every 10 times. So it's going to be 10 times slower. Okay, so let's check that out. As soon as we refresh, it should be a lot slower. See how slow that is? So that's probably too slow, depending on what you're using it for, of course. If it's a video game, that's probably way too slow. But what we had was kind of way too fast. So somewhere in between there, closer to the faster side, I think. But hey, let's cut that in half. Let's see where that ends up. So let's set it to 5, save it, and then we'll hit F5 on the keyboard. Did that refresh? I think it did. Yeah. So then we can also say, let's say every 3. Let's see if that jumps up in speed at all. Let's get a sense of the speed first. Let's see if it doubles in speed. Maybe not quite double, but pretty close. Pretty close. I'd say that's a comfortable thing to at least look at. It doesn't seem like, whoa, 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 whoa. At least you see it's growing, and your eyes can pause long enough to, I don't know, it's still kind of jittering, I guess. But your eyes can still pause long enough to see what it is. And most of the time, we don't just have continuous action like this, like it does something and like it'll sit there and sway, or it just won't keep doing the same cyclic action. However, so there's one thing I would like to do. Instead of it just go to the end and then jump all the way back to frame 1, I would like to actually see it shrink back down. So this is actually a problem in a certain way. This is a problem that happened here. I wasn't intending for this thing to turn the direction it's turning. I would actually like to see the big dot chase the little dot, not the little dot chase the big dot. That's just how I would prefer to see this particular animation. So there's a logical thing we could do in code to say, hey, go reverse the frames instead of going plus, start at frame 79 and go minus all the way back to frame 1. I think you get what I'm saying. As soon as it does that, then it'll just reverse the order and draw it the other direction, and everything will be fine. So let's go ahead and do 1 to 25, and then 25 back to 1, and back and forth like that, instead of this all the way up and chop, all the way up, chop. So let's do that, and then we'll call this one done. But at least you're seeing the code now, and I'm happy with that. I'm happy we're getting through the code. Everything's working the way I would have expected it to be. Let's see here. So we're going to have to modify this statement here. This is what's killing us, because it's saying if this is greater than or equal to, and then now we're at 25, right? Then set that back to 1. Well, that's not what I would like to do. What I would like to do is probably set a direction var dir, and then set that to, and I'll just put a quick little note here. 1 equals forward, and 0 equals backward. Okay. So when dir is going in the 1 direction, is going in the forward direction. We're going from frame 1 forward to frame 25. Now if we're 0, then we're going backward from 25 back to 1. So we're going to say, we're going to have to now start trapping that. So we're going to have to check our direction first. If dir is equal to 1, then JavaScript's kind of funny. We have to check equality to numbers with 3 equal signs. With strings, you could get away with 2. It's weird. I think you can always use 3 when you're checking equality, though, even with a string. It's probably a good habit to get into for that. Anyway, so if the direction is 1, and then this dot fmax is greater than or equal to fmax, then let's see, we need to set the, instead of this, and I'm just going to comment that out. I'm going to tab this just to structure it better for right now. So I'm going to comment that part out. So instead of changing that, I'm going to change the direction. So dir is now going to be equal to 0. It needs to go back the other way, right? And we need to go the negative direction. So this dot frame equals this dot frame minus 1. Okay. Otherwise, if the direction is equal to 1 and the frame is in a valid place, then this statement still works. Okay. Else if, or really, if the direction is not 1, it's 0. So we could just say else. Okay, if this dot frame is less than or equal to 1, we need to do the opposite of what we did up above. So direction now needs to equal 1, and this dot frame needs to go in the positive direction. Okay. Otherwise, allow it to keep going in the negative direction, which is this dot frame equals this dot frame minus 1. Okay, let's see if that works. I sure hope so. Hey, much smoother. Now it looks like a dancing monkey plant. All right, so now we're done. Thanks for hanging out with me. Anyway, I hope this all made sense. If it didn't, we can discuss it. So write down any questions you may have, and we'll try to go through them. I'll try to explain the things that might be concerning to you. All right. Well, I will call it good. Thanks, guys.